Hello everyone. Today we are going to learn about general quadrature formula for equidistant ordinates. Now general quadrature formula is a very important formula of numerical integration. As using this formula we are going to find out several other formulas for finding the values of numerical integration. Okay, so what happened in this formula, as we all know, in numerical integration we divide the range of the definite integral. Suppose a range is given a to b, this range we divide into some small parts. Okay, so here suppose I have divided this range a to b into small n parts, and the difference between each values of x will be here h. Okay, now see, let f of x naught f of x x naught plus h dot 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 f of x naught plus nh be n plus 1 entries corresponding to the equidistant argument a is equal to x naught plus h comma x naught plus twice h dot 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 x naught plus nh is equal to b. Here last value is b, which is equal to x naught plus nh. Here see, first value is a, which I have taken as x naught. So second value will be what? Since the difference between the first and second value is h, so second value will be my x naught plus h. Third value will be what? X naught plus twice h. Okay, this h plus this h, x naught plus twice h. Similarly, the last value will be, since I have divided this into the range into n parts, so last value will be x naught plus nh, which is nothing but b. Okay, first value x naught is a. Okay, and corresponding values of fx is what? F of x naught plus h, f of x naught plus nh. Okay, I have got n plus 1 entries. Now in this formula, let us to find out the formula, let us take a definite integral I is equal to, suppose the indefinite I is equal to a to b fx dx. Here the range a to b I am going to divide into n equal parts. Okay, then I will get n values of the argument, equidistant values of argument and equidistant values of entries, suppose, and these are the values of entries and arguments. Okay, now I'm going to integrate this. Okay, so in place of a I can also write x naught, in place of b I can write x naught plus nh fx dx. Okay, so I'm going to substitute this value x in terms of u, where u is equal to x minus x naught divided by h. So x will be what? X is equal to x naught plus uh. So in place of x now I am going to write x naught plus uh or hu. Okay, now if I differentiate I will get dx by du. With respect to u, if I differentiate I will get dx by du is equal to h. So dx will be h into du, and the range will change then. If when x is equal to x naught, u will be 0, x is equal to x naught plus nh, u is will be n, and putting this value I have got these integrations. In place of x naught I have put now 0, in place of x naught plus nh, and since I have substituted in terms of u now, so in place of x naught plus h, and in place of dx h into du. Okay, now this is, if you remember shift operator, this is a this we can also write using shift operator or e operator, we can also write like this way. Okay, e to the power u f of x naught, and e is equal to delta plus 1. This is according to relationship between e and delta. Okay, and h is constant that comes outside the integration sign. Okay, now delta plus 1 whole thing to the power u, I have expand this using binomial expansion. Okay, and according to binomial expansion I have got these expressions. Now I am going to integrate this individually with respect to u, and after integrating I have got this h into u f of x naught plus, in for u square by 2 delta f of x naught, for here u into u square minus u, 2 factorial here is associated with here delta square f of x naught, and u square will be u cube by 3 minus u square by 2, and similarly all the other terms. Okay, and the range is 0 to n, since this is a definite integral. Now putting the values I have got this expression. Okay, now which is known as general quadrature formula. Okay, if you are asked to write down the statement of the general quadrature formula, you have to write down this part. Okay, along with the first part, along with this part you have to write down this. This is the statement of the general quadrature formula, which usually asked in the exam. Along with this, the derivation is also asked, so go through it. Okay, now putting n is equal to 1 to 3 respectively in this formula, we can find out some other formulas through which we can find out the values of numerical integration. The first method is trapezoidal rule, second is Simpson's 1/3 rule, and third is Simpson's 3/8 rule. There are other methods also which are not required in your syllabus. Okay, so this method we will discuss individually.